Alrighty, let's see. We got a good 4 streak going before having to deal with the hard to break the streak. Well, let's see if we can do an actual hard problem these days. Maximize the number of partitions after operations. Given a string s and an integer k, you are allowed to change at most one index in string s to another lowercase English letter. After that, do the following partition operation until s is empty. Choose the longest prefix of s containing at least or at most k distinct characters. The longest prefix, delete the prefix from s and increase the number of partitions by 1. The remaining characters, if any, in s maintain their initial order. Return an integer denoting the maximum number of resulting partitions after the operations by optimally choosing at most one index to change. Okay, so I can change one thing until s is empty. Okay, so I really don't know what's going on, so let's go example. ACCA, ACCCA, k equals 2. K is supposed to represent the longest prefix containing at most k characters. So I guess you can choose, well, I mean, you can use all of it as the longest prefix, delete the prefix from s, and increase the number of partitions by 1. The remaining characters in s maintain their initial. Okay, so explanation. The optimal way is to change s sub 2 to something other than a or c, for example b. So it becomes ACBCA. Then we perform the operations. Okay, so that was the first part, changing one letter in the string to another letter. So after that, do the following partition until s is empty. Choose the longest prefix that has at most 2 characters, that's AC. Delete that and increase the number of partitions by 1. What does it mean to increase the number of partitions by 1? Remove AC, it becomes BCA. Now the longest prefix at most 2 distinct characters is BC. So remove that and it becomes A. Finally remove A. Doing the operations, the string is divided into 3 partitions. So the answer is 3. So we return the maximum number of partitions. Okay. So here, what's 1 really? K equals 3. So if I change, let's say, this A to C, then be ACB. And then the next time it'd be just AAB. S contains 2 distinct characters, so whichever character we change, it will contain at most. Oh, right. So, yeah, so it never gets more than 3. K equals 1. So change like an X to an A or something. The maximum number of partitions. Trying to think whether or not. So it's a pretty long string. Wonder how hard it'd be to just brute force it. Like for every index, try to change it. Let me think here. So this was the only really interesting example. The other examples were kind of dumb. So ACC, CA. So since it's 2, what is the logic here? Change at most one character into another character. Find the longest prefix with k distinct characters, delete it, and then redo the process. Interesting. So you start with I think maybe this is a sliding window. Slide the window out. Okay, so if you initially change one of the C's here to a B, then it'd become a BC and then a BCCA. So that wouldn't have helped. Yeah, so you need to have changed this C. If you changed the first C, then that would not have worked. Could you have changed this C? So this AC, you need to change one of these two C's. Like one of these two needs to be something else. And then A would be the last partition. I wonder if you can do a greedy approach the first time you see like a duplicate. Just change the first time you see a duplicate. So you do AC, you don't see any duplicates. You do CC, since there's a duplicate there, you change it. No, you do CCA. You do CC. There's a duplicate. So you change the duplicate. Oh. First allowed to change at most one character. In theory, if the string is 10 to the 4th, you could do all possible changes for every index, change the character at the index to another one of the other 25 characters. And if it was a linear time complexity for evaluating the number of partitions, then it'd be 26 times 10,000, 25 times 10,000 operations, approximately. I assume that has to be pretty bad, though. Delete the longest prefix of S containing at most k distinct characters. Okay, so let's say the string is, I don't know, maximize. And let's say k equals 3. So with no operations, that'll be like max I M I Z and then E. Is there better? I assume there can't be a better split than that. Because in theory, maybe the I becomes something else and it becomes, and then makes this thing shorter. It makes it like IMA, maximized, and then the last bit would be ZE. Let's say the string was max maximize. So then with no operations, it'd be max with double X, IMIZ, and then E. We have one operations. Let's say you make one of the X's to K. And then that'd be max K I M I and then Z E. What if it was Mac X I M I Z E? So it's the same. At most one operation. Yeah, I really need to. This thing is really the thing. String is ACCCA. No operations, it would be literally the whole thing. You need to change one of the C's. So let's change second C. Yeah, you have to change the second C. Well, I mean, you could change the first C and you get two partitions, like AB and then CCA. So then you get AC if you do middle C, and then like KC and then A. Hmm. I think so. If I do a pass or just try no operations, what would that mean? If I do a pass and I try no operations. Wonder how much things change depending on where the index of the modification is. Is it possible to what is K at most? K is at most 26. That's kind of stupid. If K is 26, then I would just return 1, right? Like, the whole thing is partitioned. You can't, there's just no way that you would have multiple partitions if every letter in the alphabet is part of the prefix. So then I know that there has to be some letter that is not part of any prefix. So and notes A equals 26 is a trivial case since since all letters must be part of one partition. Thus, any other case will have K less than 26, and there will be some kind of excluded letter from original string. Maybe not as original string, but original, yeah, from original string, right? Like it could be 25 different letters in the string. So there's guaranteed to be one letter that I can change it to guarantee a partition at a certain point, because that letter has never been used. There must be some letter that has been unused in the string, such that changing any letter to some special letter, let's say asterisk, such that changing any letter to that will cause a different partition, will cause a kind of partition. Okay, so I can guarantee that. So then it boils down to, like, if I change the string at every given index, see how many partitions would occur. So I don't need to worry about how I change it, like what letter to change a particular original letter to what. So like for every index, I can just say this is the index that I change. I don't need to worry about what letter I change it to. I just know that it's going to be changeable to a letter that hasn't been used, or or that would cause it to be a kind of unique letter. So how many partitions would occur based on the change at that index? A, C. So if I change it at the first letter, if I change at the first letter, then so what am I thinking about here? If I do a single pass for each index, where the pass takes the length of the string, and then changing it would be, that'd be 10 to the 8th, I guess. It'd be like an n squared deal for every index. Find the number of partitions based on the change on that, at that index, assuming that I can linearly determine how many partitions would occur based on any given change. Yeah, that'd be n squared. So 10 to the 4th times 10 to the 4th would be 10 to the 8th, which is 100,000. All right, 10 to the 9th is a million. 10 to the 8th is 100,000. 10 to the 4th, 10 to the 3rd is 1,000, right? 10,000, 10,000 is, that shouldn't be 100,000. What the hell's going on with my brain right now? Oh wait, 10 to the 9th is a billion. And that's 100 million. Oh my god. Oh my god. Yeah, that's too slow. That would be too slow for sure. X, X, Y, Z. So A, C, C. Would it make sense to try to do the C here? The first time you see a duplicate, you just try to make a partition based on that. You change that index to be something else. I mean, that's kind of a greedy approach to it. But is it any worse? Is it possible that it's better to keep the duplicate? So I guess, so would a greedy approach work? This is first duplicate letter gets changed. So in other words, can I find in counterexample can let's name a counterexample where not changing first duplicate is correct. So if the string is, I'm going to say k equals 2, since I think it's a little too hard for me to think of anything more complicated than that. Let's say A C A. So if I change this A to become a B, then this will become AB as the first prefix string, and then CCA would become, so the number of partitions there would be 2. But if I change this C, like if I made it AAC as the first prefix and then made this C into a K, then it would become KC and then A, and then that'd be 3 partitions. So that's definitely an example of one where you wouldn't want to do the first duplicate. Maybe it's not the first duplicate, but the first duplicate after you see K letters. Yeah. First duplicate after K characters have been seen. K unique characters. So if it was K equals 2, string is AACCCA, then you'd make it into AAC, then you change this thing into a K, so that'd be AAC, and then you see, and then the next one would be like KC, and then it'd be A. And if it was, let's say K equals 2, and the string is AACACCA, then you go AAC, and now you've seen K different letters. A is a duplicate here, so you change that A. So now you stopped at AAC, and then the next A becomes a K, CC, and then an A. So that might be it, because you kind of want to not change too early, I want to say. There's no, I think that might be right. Okay, well, I'm gonna try this and see if, try and see what issues come up. I think it's better, given the Leetcode environment, to just test it and see if there's, instead of trying to theorize what the test cases where this approach is wrong, then I'm just gonna let them tell me. So how to do this? I think here the answer is the number of partitions, and then have a current set, and then let's say n is the number of letters in the string for every index in the range of n. The letter is the string at this index. I'm going to I'll do the edge, the break case. So if the length of the current set of letters is equal to k, and this letter is in k, in the current set, which just basically means it's a duplicate. This means that I'm going to actually, I guess, do I want to do this in two pass? Like one pass up to the change and then another pass after the change, I guess. Sure. So at that point, what happens? So at that point, the answer should increment. Actually, I'll just have a Boolean here. So if I haven't changed anything, and the current set of seen letters is k, and now I see another duplicate letter, then change is now going to be true. Answer increments. Answer increments. I think I reset the current set. The current set is a new set. And I'll actually include maybe an asterisk as to what the new set has changed the letter to. I think that's right. I think that's right. I think I need, this is just bad. I think I need to have a separate for loop. Yeah, I think I need to have a separate for loop. Maybe have a while loop. While less um here. So let's just do one for loop for the initial change. So if the letter while index equals 0, while index less than n, and the current set while index less than n. Letter equals s at index. I guess I probably I probably just use an if statement to break. So I'll just assume that I add the letter. If current set, if the letter is in the current set and the length of the current set equals k, then this is, so I'm going to change this letter. So that means that I need to break. So here, I guess I assume answer should start with 1 because this is just automatic, right? So this letter will be changed. I think maybe index always increments here. Letters in the current set. Yeah, otherwise the letter should be added to the current set. And then this is going to be the second pass. So this is everything after that. So at that point, the current set should be just like a wildcard for what the letter changed to. And I'll say while index is less than n now, letter is equal to s at index, index plus equals 1 if the letter is in current set, then I guess, let's see, if the length of the, no, I think it has to be letter k could be 1. Huh. I guess maybe k equals 1 is a trivial case as well. No, it's not trivial. Fuck. Alright, k equals 1 is not trivial. Okay, so I think I need to start with if the length of the current set is equal to k, then current set needs to reset. No. If the length of the current set equals k and this letter is not in the current set, then it needs to reset. So here it would say the current set is whatever this letter is. Answer needs to increment. Yeah. Otherwise the current set adds the current letter. I think that's it. If it's not, create a new partition. And I think I need to do something where what is going to be, I think answer needs to increment by 1. Answer increments by 1. I'm miscounting something. I'm almost certain of it. It's like I'm not counting the number of partitions correctly because of when I'm setting the current sets. Like it's not counting it correctly. So this thing counts it up to the first breakpoint, creates the breakpoint, and then this thing counts, it creates the partition, and then the letter becomes a new partition. But then this new partition doesn't actually have, it's not counted. This new partition isn't counted. Is it always the case that I'm miscounting by 1? So answer starts with 1 because you'd always create this partition. I guess here if the index was already at n, then there wasn't going to be a second partition. All right, let's go ahead and just see what happened with this thing right here. So like the ACCA. So it would do A, C, okay. So it would pass through A, and let's say K is 2. It would do A, C, and then at the second C, it would change, it would break. It would treat that second C as an asterisk. The index is correct. So it'll start at this index next. It'll be the C, and then it'll add the C to the partition, so, or add the C to the current set. I guess I could call the current set the partition. Partition set. So it'll get the second C to become the partition set, and then it'll be at the A, and then the A will cause it to be creating another partition. The answer would be 2 at that point. And then index goes to n. The partition set will be A. So it should be answer plus 1. If the index, I think it should be at the letter. I think maybe it should answer equals 0 here. answer should equal 1 here. I think that might be what was the issue. There's one partition. It's not quite it. I think it might be answer plus 1. All right, what's going on here? Line 7. It's called S. Index less than n. N is the length of the string. Oh, whoops, what am I doing? That's stupid. Okay, well, it does the simple cases correctly. Okay, so it did most of it. This is kind of like a trivial case. Looks pretty trivial. K equals 1. So I think gave an output of 1. There should definitely be 2. So oh boy. Just changing the math, how I'm calculating the answer is just going to be rough since it worked for 195 cases already. The reason I put it here is I don't even know why I put this thing here. Letter, this index will be the change letter. I guess if I said I'm not sure. There's just I'm blanking the logic here in terms of how I should be setting up the answer calculation. So you start with 0 partitions. You go to the first wildcard, or the first kind of spot where you think you should have a partition. You break at that spot, so you keep the index at the character where you want it to be changed to a wildcard. Otherwise, you keep on going, adding every letter to your partition set. So, sorry. This point index should point to letter to be changed to asterisk. So you guarantee that the answer should be 1 at this point, no? I mean, there's just no way the answer is just not 1 partition at this point. I guess the question is, when do I want to just return 1? Because like this other stuff probably is going to cause more partition counting. So if the index is n, if the index is n, does that guarantee it? I don't think so. Unless I move that there. So that means that this thing, if the index is n, it would have reached the end. And if that's the case, then the answer should be 1. Because that means that I've gone to the last, I've gone through the whole, is that right though, actually? No, that's not quite right. I guess maybe if the index is at the end, if the length of the number of different letters is less than k, then returns 1. Otherwise, if it equals k, then it returns 2. Because it could be something like AAC or k equals 2. If it's AAC and k equals 2, then you change one of the duplicates. No, that's not quite right either. If the length of the partition set equals k, less than k, then return 1. This is, I think that's right, because like this means that any character that you could possibly change, it would still change to be a different character, but then you'd have like some number plus 1, where that some number plus 1 can still be less than or equal to k. I think this thing would be else if the length of the string is greater than k, then return 2. I guess maybe this should be else return 1. If it's equal to k, what happens if it's equal to k? Length of the partition set is less than k. The number unique there is less than k, so even if you change 1, you're still getting on that first partition. In order to have at least 2 partitions at this point, you need to have at least k plus 1 characters. Because if it's at least k plus 1 characters, then there's a guarantee to be a duplicate at some point. This is kind of guaranteed duplicate exists by the pigeonhole principle. And if there's a guaranteed duplicate, then the duplicate can change. I guess maybe if the length of this thing is greater than k and the partition set is equal to k. Well, I mean, the partition set has to be equal to k. If it's not less than k, then it has to be equal to k, right? Because if it's bigger than k, then if the letters in partition set and length of if the letters in the partition set actually, I'm not sure why this works now that I think about it. Because what happens if it's just ABC What happens if you have a string that's ABC in the case 2? Because if you have a letter A, B, if the letters in the partition set, actually, all right, just forget whatever I did. I must be doing something wrong here. ABC. Okay, yeah. My logic is just wrong. It took a lot of cases to get there, but that thing is still wrong. If the letter is not in partition set in K, letters in partition set, I think maybe this should be an OR here. So I think it might be something where if the length of the partition set is equal to K, this means it's kind of full. If it's kind of full, then either this letter is a duplicate or this letter is not in the partition set. What the hell? That's both cases. That's both cases. I guess that just means it boils down to this then. If my partition set is full of K unique letters, the next letter is either going to be a duplicate or it's going to be a new letter. Okay. Then the next letter has to be the letter that I break on. Okay, that's right. Okay, I think that's better. I don't know if this answer should be 1. What happens if it doesn't break here? If it doesn't break, then it'll return 0 plus 1, which is 1. I think maybe this should just be 1 here. Something like this. Maybe. No, that's not right. That's not right. Yeah. This case is the case where I don't have to. Yeah. Okay. I think this thing needs to have some logic here. Logic for one partition. Or one max partition. So if the index is n, I think I need to actually change this here. So I know that the index reaches n. So this is only the case if it doesn't break. So if it reached the end and so if it reached the end, then either there's going to be 1 or 2 partitions. Logic for only one max. So if it reaches the end, then if the length of the partition set What am I looking for? So I didn't reset the partition set at this point. So the partition set at this point contains all the letters within the string. And if all the letters within the string is less than k, then changing any letter will not give you another partition. Right. Because changing another letter, changing any letter would give you at most k, but not more than k. So then everything would be part of that first prefix. So if the length of partition set, so the only other thing here would be if the length of the partition set equals k, and if it equals k, based on like the final letter kind of causing that to break, well, based on the final letter causing it to be k different letters, maybe, then what would happen? So there's going to be k letters. I think at this point it needs to be it if the length is less than k, or the length of the string is greater than k. Because if this is false, then the number of unique letters is k. In order for you to have a partition, two partitions, then you need to have k plus 1 letters. If you had exactly k letters in your string, then there's no guarantee that there's a duplicate at all. Well, there's a guarantee that there's no duplicate. Okay. I think that's right. Okay, I think. Gosh damn it. K equals 1, x, y, z. Oh, that's way too big. That's way too big. So I said an answer is equal to 1 here. So it's definitely not screwing up because of this logic. I don't think. So the answer is initially 1 here. Let's go ahead and just print out here. Print out the index that I'm dealing with. This should be index 1, I want to say. So it's at this point. So there, it's going to treat this as the wildcard. The letter at this index is x. Okay, I see. Yeah, I initially had index plus 1 before the break here. I think this should be index plus. I think I need to increment the index. Yeah. All right, well, more test cases passed. BAAC. k equals 3, output is 1, expected value is 2. I thought this would return 2 actually. Because the length of s is greater than k, I think. Oh, whoops. My logic is wrong. Is equal to k. I have that backwards. Okay, well, more cases passed. A, C, B, A, B, B. K is 1. So I had 5, it had 6. So A, C, okay. I think I know what's the matter here. And it's something I hadn't considered. I think this one's going to give me index 1 maybe. And that's definitely not the place where I want to change. But it is probably the place where I considered changing. 2. That's kind of odd. So k is 1. Index 0. Partition set is going to be A. Next pass index is 1. Letter C. Length of the partition set equals k is true. Is equal to, yeah, that's true, so it breaks. Doesn't have index equals n. Partition set, oh, okay, yeah. This increments the index to 2. Yeah. If k equals 1, k equals 1, so it should be changing like this b. In which case it gets to 6 rather than 5. So the greedy approach might just not be correct. Or I'm thinking about changing it at incorrect times. I think k equals 1 is just a odd case. I wonder if my solution just works for k equals bigger than 1, but this is just like a case I need to handle separately. A, C, B, A, B, B. So if I handle this separately, it would be the first time I see a duplicate. The first time I see a duplicate. Maybe. A. Definitely need to do a different partition to make it into, to make C. And then if you need a different partition for B, different partition for A, different partition for B, and then the second B, if you change that, that's when you actually want to change it. I guess what I could do, it wouldn't be pretty, but I could count the number of uniques I'm dealing with. If I'm dealing with the minimum number of uniques within the current partition, and then it does the exchange, then I don't actually break. I just, like if your K is 1 and you deal with one letter before changing partitions, that's going to maximize your number of partitions anyways, so you really don't want to use your wildcard on the next character. Or if your K is 2 then and you see AC and your next character is going to cause you to change partitions anyways, you don't want to use your wildcard on that character. There's just no point in that. Yeah, so I'm just counting. I don't think I'm identifying the correct index to make a wildcard. Yeah. So if the length of the partition set is equal to k, if the length of the partition set equals k, I guess if the next character is part of it, then that is when if the next character is part of the current partition set, that's when I want to break. If letter is in the partition set, that's when I want to break. But if its letter isn't, if the letter isn't, then I want to reset. I want to increase the number of partitions, and I want to treat this as a new partition. I guess since I have this thing afterwards, I want to reset like this. Okay, I guess this is still correct. I guess answer should be whatever I get after I do the while loop here. Well, it might be that I need to have answer start with 1 here. So the answer becomes 2 here. I don't know. Partition set add letter. Oof. So this thing went back to being wrong. A, B, C, K is 2. So the answer is originally 1. And then letter is A, letters B, letter C. Answer increments to 2 here. think the answer increments to 2. Okay, the answer increments to 2. The index goes to 3. Fuck. Okay. Partition set reset to be just C here. Okay. Maybe this is just incorrect logic at this point. I guess maybe if index equals n, then return there's some let's see. I don't think this is right. I'm almost 100% certain this is incorrect. That being the case, it did do most of the cases correctly. BAAC. Ah, fuck. So the index so this is at the very last index. Okay, this is at the very last index. So it's 2. Huh. EAAC. A is 3. So it got to the last thing without breaking. No. The length of the partition set is K. So what B A letter C, length of partition is 2. So that's not gonna hit. Index is N. The letters are BAC. Answer still 1. Answer still 1. Test case. I want to make note of this test case. AABCK equals 2. Or maybe AABCD. I think I get that wrong. Yeah. Because it's going to do AAB. is going to do CD, but in theory the AAB needs to have changed to be like AKB CD. Yeah. Oh my god. So the greedy approach is failing pretty hard here. Or the logic of when I need to change is just not consistent. There's just a lot of edge cases, and if there's a lot of edge cases, then it's a hint that you're just not getting the general solution right. Oh boy. AABCD. So I wonder. I wonder. All right. What if I did a different approach here? All right. Like, hmm. I think I wonder if I just worked backwards here. Like this is just, I don't know. I think maybe I should just be counting how many partitions there are up to a certain index and how many partitions there are if you change that index. Like just do a brute force method kind of. If the wildcard is at position 0, wildcard is position 1. A, B, C, D. So the number of partitions up to every index without any modification, the number of partitions after that index with a modification at that index. Maybe. Yeah. So I think I need a backwards traversal. Right, I think maybe I need to do a forward one. The forward one should be pretty easy. For every index in range n, n is the length of s partition before. Maybe it should be 1. I'll do 0. So index equals, let's say letter equals s at this index if, let's say, uniques is a set, which is the same thing as the partition set before. I can say if if the length of uniques equals k, what is going on here? So for each index, I take the letter, I add it to the unique set. But then if the unique set has more, then that's when I need to reset it, right? So yeah, so the uniques always add the letter, and then if it's more than k, then you need a reset bag of letters. So the partition increments, and then whatever the part before of this index equals the number of partitions. So if it's like A, B, and K equals 1, A is added to the uniques, B is added to the uniques, or B would be added to uniques. That would be make it too large. You reset it, you make uniques just the B letter. And then, so that means it's inclusive of the number of partitions, including the letter at that index. I think that's fine. So going backwards for the other part, for every index in range n minus 1, guess I do the same thing. Letter is equal to s at this index. Uniques add this letter. If the length of uniques is greater than k, partition adds 1. Uniques reset to this letter. And the part after and then I do maybe the maximum of like part before and part after. Maybe something like that. This is just the answer variable. If if current total is part before this index plus is the indexing is off here. Can't just do part after index plus 1. I don't think. Well, is there at least 2 characters? No, there could be only 1 character. I think maybe I could still do -1. This is almost certainly incorrect at some point, but the idea might still be okay-ish. ACCA. Okay, so let's go ahead and just check what the hell's going on with the part before and part after. Oh, yeah, that's pretty bad. Initially there's one. I'm not sure why it didn't go more than one. I guess these are all ones. No? Really? Oh, yeah, okay, ACCA. Okay, case 2. So there's all one part. Yeah, okay. So it doesn't work if I just add 1 to this. ACCCA. AC. So if the wildcard's here, the wildcard is there. Then the wildcard would create another partition. AC. AC. I'm thinking maybe it's because at certain locations, like this general idea of having the number of partitions before here and then like a changed letter causing a different partition, that only occurs at certain breakpoints. At the breakpoints where you are dealing with a full partition, where if you have a full partition, then changing at that index will cause you to have an additional partition. But if you're not full of k different unique letters in your partition, then it doesn't affect it. So for instance, AC at this point you're dealing with a full partition. So that is the only C where you if you change it, you actually are creating a new partition. Or I guess this C if you kind of think of it backwards. But this C, you're not dealing with a full partition in this direction. Huh. AC. So if I change it to be like 1, 1, or 1 not full, 1 not full, 1 full. So then you do the sum of the number of partitions here plus the number of partitions here plus 1 if you're dealing with a full index. Yeah, all these are just going to be off by 1, I guess. Because otherwise, all these are off by 1. So I guess you're really just asking, is it possible to create an additional partition at any point in this process? Right? Because you're changing at most one character, and it's not like you're going to get 2 new partitions based on that one character. I don't think. It's always going to be off by 1. So A. So, I mean, in that case, it should be a greedy approach. Like, you just need to find one partition, one partition, one partition. I see. Some partitions here. It's not even. AAB, AAB. If you have the number of partitions before index, you change that index, change the letter index K or index K. No, index K is already used. Change the index H, and then you count the number of partitions after index H. And then you'd add the sum of the partition before and after. If they can't already be merged in some way. AAB. Alright, so if you didn't change anything at all, didn't change anything at all. There's some baseline number of partitions. And then you change one. And then the question is, how many partitions can you get with changing one? I think you can get additionally just one more partition. So the question then is, how do you identify the index or the conditions where changing one increases your number of partitions? Changing form letter will at most increase max partitions by one. Question is how to identify what index to change or under what conditions change will result in that extra partition to exist. What is the common denominator? So here it's k minus, or there's only not a full k set of unique values, so therefore changing anything doesn't change the number of partitions. Here k is 1. K is 1. So if I see a duplicate, a back-to-back duplicate letter, then obviously I should be able to change that from one partition to two partitions in that exact location. And that'll increase the number of partitions by one. Then the AC so if there is some partition that I counted, no. Because if so in this exact circumstance, I can change an A into like a D, like BAD, and then C is an extra partition. But if this was an extra letter, like BAC, BACK, or BAC, some extra letter, normally the number of partitions there would be 2, and then modifying it would change the number, the kind of placement of where the partitions are delineated, but the number of partitions would still be 2. So like it has to be something where maybe change the first or last partition. Or if you change the middle partition, wouldn't that, if this was in the middle, like BAAC, but you have like XYZ before that and XYZ after that, I think changing A to D would cause another partition. Yeah. Hmm. I guess another thing I could possibly do, or a different approach to it, would be just counting what letters are in which partitions and ignoring duplicates within that. So like the number of uniques that I'm dealing with. I think that might work. If I go through and count the uniques, the unique consecutive letters, if it's a multiple of k, then possibly changing one would break that multiple and I can get maybe another partition. As long as there was anywhere within that chain where there was a that's not quite it. That's not quite it. Fuck. That's so close though. Because ABA is still going to be the same thing as So if I go through the indices, man, that was so close. If I just count the placement of the uniques. So like this if I consider this as just be BAC rather than BAAC, or like this could be 2 A's or this could be 4 A's or some number of A's and some number of B's and some number of C's, but the order of those values are BAC. The order of those unique values are BAC. And then somehow work with partitions based on that. Then if your partition already includes an A, then more A's later on aren't adding to the partition or can't really differentiate. BAC. So XYZ, oh, K equals 3. So first prefix is XYZ, XYZ. Next prefix is BAC. Next prefix is XYZ. Theory, you can change like a Z to, let's say, P. First prefix would be XYZXY, then it'd be PBA, then it'd be CXY, and then it'd be a Z. at most one partition. If I change for any given partition, I would have to change something that's duplicated within the partition. If there's no duplicates in the partition, then that partition is like the minimal partition, and you should definitely not mess with it, or it's not going to be optimal to mess with it. But what if those things are overlapping? What if it was something like AA? So XYZ in theory would be a minimal partition, minimal optimal partition if it was at the start. And then if it was like XYZ, KXY, then KXY is also a minimal optimal partition. XBA A would be possibly improved if this A became a wild. So then it'd be XBA would be XBA. Is that guaranteed to be better? So I mean, I could do a greedy approach where I just try to find, where I find a spot where the maximum of partitions, or where changing is an optimal change, in the sense that changing it, if it could result in a higher partition amount, then it would. Doesn't guarantee it that it does, but if I just count the number of partitions based on that change, then it's going to be correct. And I think it's always fine to change something where you see a duplicate as the next value, I think. If you see a duplicate as the next value where your current partition set already has k values. Then there's the case where it's something like AABCD. So you go AAB, and then you C is a different value, so you say start a new partition there. But in theory, you could change like this AA to be something else, in which case you would have gotten a different partition name. AABCD. I mean, if you do maybe one traversal forward and one traversal backwards, so it'd be CD, then BA, then A. There's probably some case where it's just neither forward nor backwards, but still somewhere in the middle. like Z AAB C AAD. So it'd be like ZAB, and then you see a C, so you have to force a different partition change. And then CAD, and it's another partition. Then you say there's 2, but technically there could be 3. If you change either of these A's or either of these A's to K. So partition. Yeah, the issue is like when you make the wildcard change, changing a letter to a wildcard, it really alters where the partitioning occurs later on. It's like your partitioning is dependent on where you're on. Your partitions are, the boundaries of where your partitions are dependent on what letter and where that letter changed. So it's not, so like this partition after array kind of assumes that there's some sort of independence between those two values, the number of partitions after an index and kind of the change at the index, which there isn't. AAB, AAB, so you could change the second A to be a wild, and then the B, C is a different thing. Then you just can't change, can't always do the greedy approach. Like, what was it that AAC, yeah, AACCCA. You change the second A, and that still gives you K2 partitions. Two partitions. Can't change the first duplicate. Can't wait. Sometimes the first duplicate is the correct thing to change. So yeah, this case, you can't change the first duplicate. If there are examples where changing the first duplicate is incorrect, then how do you recognize that this is when you should be changing the first duplicate? We change the first duplicate here. So that'd be A C, one partition, CC, AA, one partition, CCCA, two partition, AAC, one partition, CC, two partitions. A, one partition, CA, one partition, this dynamic programming. This is dynamic programming. So what's the states here, and what's the relation? I forget what the term is. Recurrent relation. Term. Recurrence relation, right? So I think if I do dynamic programming, the state of it should include the index, the number of partitions, if you use the operation to change, and like maybe somehow the uniques. What else? What other information do you need to have? Something like that. So basically the uniques is kind of hard to quantify or hard to use as a single kind of variable in your state of your dynamic programming. So if you're at a certain index, or up to that index you have a certain number of partitions, and up to that index you've yes or no true or false, you use your change. Then you could be the number of partitions that you have for the index plus 1 is equal to the number of partitions at index plus 1 if somehow changing the character at this index creates a new partition or something like that. The uniques within this is kind of bothersome. The uniques would be, yeah, it's just not great. So that's too much information to pass through on it, on a relation, I think. But you kind of need that information. So AACCCA. So in theory you could change the first index A to wildcard, and then you go to the next index where the set has just wildcard. It has one partition so far. You have used the change, the operation. Huh. Used operation. Do 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 do. If I know if I know let's go last spot. There's a default dictionary. I want to say this should be -1. I guess maybe I can do -1 times 26 for every previous is -1 times n. This is all just very theoretical work. For every index in range n, I want to find the last occurrence of this letter. Previous, let's say ord value is, let's say letter is s at this index. Ord value is ordinal of the letter minus ordinal of a, and the previous of this is equal to the last spot of this, and the last spot of this is equal to the current index now. Last spot ordinal value. Ordinal value should be 0 to 26, I want to say. Ordinal of the letter minus ordinal of a. (23) last spot of 23 is out of range. Last spot (-1 times 26). I must be doing something kind of stupid right now because I don't recognize what I'm doing wrong. Okay. Ordinal value is 23. Previous ordinal value. List assignment index out of range. Oh, it's times n. I got. Well. Oh. Yeah, it's stupid. Okay, so this is a array of where the previous occurrence of this letter can be found, the last previous. So A doesn't have anything, C doesn't have anything. The second C, the previous last C, is going to be at index 1. The third C, the last index of that, or the last C of that, from there is index 2, which is 0, 1, 2. This, and then this A, the last occurrence of that is at that index 0. So how does this? So if I had a DP, some sort of DP state, dynamic programming state, where it's indexed, the number of partitions, and the index of last partition, the start of last partition. That can possibly be used, or in the unique counts maybe. I think using these two in conjunction, the index of the last partition start and the unique counts, I can possibly identify whether or not the letter at the current index is part of that set of unique values within the partition, rather than carrying over the set of all partition values. I can logically determine if the index where I last found the letter at this index, the index of the last index of this letter, the last index of a letter that's identical to this in the string, is before or after the index of the last partition. If it's after, then that means it's in it. Then there has been this letter is already part of the partition. If it isn't, then this letter is the first letter of this partition. And I can increment, or if it's the first one, then I increment the unique counts. If it's not, then I obviously don't. But then even this is probably, yeah, that's really not going to work, because dynamic programming you kind of map. Might that work? So you go from, so all these are like subcalls, or not subcalls, but these like a state with this set of conditions would need to map to a future state, where the future state changes maybe certain values like the index increments, but then it's not going to necessarily always have, it's not always going to have the index of last start. Guess I could use a stack or some other thing besides could use a stack to do the recurrence relation, where the stack has a tuple for these things, and then when I pop from the stack I push down on some of these values. A dynamic programming stack? That I haven't seen. Because what you want would be like, or how the stack would end would be the somehow the index is equal to n, and then you return the number of partitions because the number of partitions is maximized somehow. Maybe you do a heap. A heap. I wonder if that would work. A heap where the partitions is the first item. So you want to maximize the number of partitions, minimize the index that you're at, so that you want to get the most partitions you can get with as little an index as you as little indexing as, so with as little characters used. And then at some point, the number of characters used is going to be index, or it's going to be n. And therefore, it would have to be the answer. The number of parts, index, and maybe used, whether or not you've changed something, which is used operation. Yeah, just get operation used. So it'd be number of parts up to a certain index, operations used, index to the last side part, unique counts, it'd be a pretty big heap because the number of parts used could be, I mean, if k is 1 and the string is 10,000 letters, then the heap is 10,000. And then the heap would even be more than that, right? Because you could have more than, yeah, that's not going to work. Guess you could use, normally you use in dynamic program matrix where the matrix has all your parameters as dimensions in the matrix. So if your index is 1 dimension, the number of parts is another dimension. That's just gonna be, no, that'd be too many entries in the matrix. All right. It's been 2.5 hours. I'm going to call that a wrap for tonight. And this is probably going to be just another failed streak, but it is what it is.